In this video, we are going to look at naming and formulas for ionic compounds, but this time we are going to look at some polyatomic ions, or ions that contain more than one atom. Most of the time, these ions are anions, and typically they're a couple of nonmetals covalently bonded, but still have a charge. So the anion here is NO3, two elements, four atoms, but two elements. Two elements here, one of each, and you can see some of these different things. Notice this one right here is just a binary one. That one kind of snuck in, just like we did before. All right, so that's what we're going to be doing, and let's take a look at the first thing. We're going to find the charge on each part. So I'm going to look for the charge on lithium. A couple ways to do that. All right, we can go up here to our periodic table and say lithium is an alkali metal. And let's spotlight this. So lithium is an alkali metal and it's in family 1, so it's going to have a +1 charge. Now you also have a common ion chart which has positive charges, or here are the cations. You have one with cations, which are positive ions, and anions, which are negative ions. But lithium is pretty common. I'll find it alphabetically. I'll also see it's +1 here. So you can look on the periodic table, or you can look here. Either way, you're going to find lithium is +1. All right, so let's do that. And we'll scroll through our anions, get back to where we need to go. Okay, I'm just going to scroll this up. Let's do a little draw function here. And I'm going to put a +1 by lithium. Okay, now I'm going to look for anions, and I see NO3. So what's the charge on that? Well, that's hard to know the charge on that. And that's right where, because I got two nonmetals, and I got nitrogen and oxygen, and I could look there and say, oh, I got to be careful because I see it said NO3. I see an NO2 up here on the top of the anions, and then I see NO3 down here, NO3 -1. And what that means, this whole covalently bonded molecule, NO3, carries a -1 charge. Now it seems kind of weird because you think, oh, oxygen's -2 and nitrogen's -3. How could that be -1? But there is possibilities for that, and we'll explore that a little bit more. But we really don't need to go into that. We just need to know this whole thing can be a -1 charge, and that is what we're going to be using here. Okay, let's take a look. And line this back up, get on track here. We have lithium is +1, and we saw from the chart that nitrate, that whole NO3, had a -1 charge. So I'm going to put that right here. So I'd write my formula. I'm going to put Li, and I know lithium has a plus or +1. I think I'm just going to put a plus. I'll put a +1 here. And then this whole thing, now I always like to take these polyatomics and rope them off, because that 3 in there is not a balancer. It is just part of the ion. And this whole thing, NO3, I'm going to rope off with parentheses. This whole thing has a -1 charge here. So I see a +1 and a -1. That is balance. This 3 has nothing to do with balance because this whole thing, NO3, carries a -1 charge. So this would be the correct formula, LiNO3. You don't really need the charges, but I don't mind if you keep them in. You don't need to put the parentheses in this case, but it's kind of nice to rope it off so that you can see what's going on. And it really doesn't communicate anything wrong if you leave it in. So I'm okay leaving that in. Now, coming up with a name, let's see, we determined how each ion is necessary to create a neutral compound. And then we had to balance it, but it was already balanced. Now we name the cation first, so that's going to be lithium. And then the anion is just the name that we found from the common ion chart. So when we looked up NO3 on the common ion chart, it said nitrate. So I just copied that down. Notice you aren't necessarily using the "ide" ending. You're just using whatever ending, let's just take a quick look at that, is on the common ion chart. So I really am just copying it right here. Oh, it says nitrate, it matches up, NO3 minus 1. So that's what I'm going to use in my name. I just copy that down. Okay, let's see if we can find this back in here. I think we're good with that one right there. And so that would be lithium nitrate. Whoops. Let's scroll back, get in range. Let's look at one more here. And let's draw here. And let's get a different color, I hope. All right, we'll try this. Calcium, if we looked on the periodic table, we'd find that it has a +2 charge because it's in the second family. I'm not going to go back there and do that. You'd probably find calcium on your common ion chart because it's strong bones, healthy teeth. It's pretty common. Now, hydroxide, I think I will go look that one up, and I'll get my spotlight. And that has a, let's see, we've got to scroll back up here. Here is hydroxide, and it is OH minus. Again, the O and the H combine to form a -1. If I put this in here, you have an O connected to an H, and this whole thing combined carries a -1 charge. We're going to learn that this is rather basic, meaning opposite of acids, at some point down the road. But let's go back here and plug things in. So hydroxide is OH -1. We stole that from there. Probably writing too much stuff on here. Let's see what we can do with this. All right. So we're going to go back and say OH is -1. And I'm going to do this kind of big here and go into the next thing. Ca is +2. And OH, because it's a conglomerate, okay, or a multi-corporation, or a polyatomic, but some combined entity, I'm going to say it's OH in parentheses, and I'm going to say that's -1. Well, if you got a +2 here, you got a -1 here, you need two things at -1 to balance one thing at +2. Now notice in total, I have one calcium, I have two groups of OH, so I actually have two O's and two H's, but we don't write CaO2H2 because that would confuse the reader. We want to actually know that there are two OH minus ions. It tells us more. The name would be calcium, first name, and then the last name would be hydroxide because that was the name we picked off of the common ion chart. Okay, let's just look at the next page, and I'm just going to do a little erasing, and maybe I will clear drawings. It's probably a little easier than erasing, so let's try this. Let's go to the next page, and I think I want to look at number 4 here. NH4Cl. So I see three elements. We usually said the negative ion is the one that has a combination. But here's an exception right here. Going and looking at my common ion chart, I think I see Cl minus. So that's the negative ion. And then I actually look at all these positive ions. They're almost all single things, except for the one right near the top, ammonium. So this is a real common ion made up of two nonmetals, but they actually combine to form a positive ion. So usually your cation is a positive, or is a metal, a single metal with a positive charge, but this ammonium is kind of the exception here. There are a couple other exceptions, but that's the main exception we're going to see to that. So how do I handle this when I go back here? Let's cruise through this. Let's get through this, find our stuff here. And I'm going to say, I'm going to go up, scroll up just a little more. And what I'm going to do is rope this NH4 off. And we said that that was ammonium. Now it does have a +1 charge. So if we wanted to record that, we could. And Cl has a -1 charge. So it is actually balanced. That 4 has nothing to do with the balancing. This whole ion, NH4, has a +1 charge. Cl has a -1 charge. But what do we name it? We just looked at the name we picked up before, and we said it was ammonium. Okay, bear with me on this. It's a lot of M's to write. Okay. Ammon. Right here. And then the last name would be chloride. So notice the last name is just a single element, so it gets the IDE ending. It's also listed on your common ion chart. So it's a little review of before. So again, these should be balanced already, and it was, and then we just name the first metal as it is, but if it's this, notice this was an ion, so we say ammonium, and then this would be chloride here. Let's look at number 21 and 22. So remember we said ammonium is NH4. We just found that out. So I'm going to go ammonium NH. And I'm going to say 4. And I'm going to rope that off. Whoops, there's supposed to be parentheses. And this whole thing has a +1. And iodide is a halogen, and we can look that up either on the common ion chart or family 7 and see it's -1. Is this balanced? Yes, a +1 and a -1. This 4 is part of the ion, so it's not a balancer. So do we really need the parentheses? No. Do we need the charges? No. But if you have them in there, it's like you're showing work. I'm okay with that. The next one I wanted to do was aluminum nitrate right here. So we'll look at this, and I'm going to write it a little bit below. And I'm not going to go to the common ion chart, but if you look at your common ion chart, it would be the very first one because it's in alphabetical order. Or if you looked in family 3, you'd see it there, and you're going to see it's Al +3. So yeah, that's how you're going to find that. Once you have that, you remember we looked up nitrate before in our first problem, and we said that whole thing was NO3. Whoops, I shouldn't have done that. I'm going to have to erase, I think. Let's go back to draw. And I got to put a 3 here. Sorry. Just testing to see if you were catching that. This has a -1 charge. Remember, this 3 is not a balancer. I have a +3 and a -1. So I have to put a 3 outside the parentheses. 3 groups of NO3 at -1, balance 1 aluminum at +3. Do I need parentheses? Yes. Otherwise, it'd be AlNO33, and it's not going to be 1 nitrogen and 33 oxygens. It actually ends up being 3 nitrogens and 9 oxygens. But we don't write it that way. We keep it as an ion like this. So that would be ammonium nitrate. Okay, this is page 7-8 of your homework packet, and work on that. Let me know if you have questions. Thank you.